So let's complete any pending doubts and questions first, and then we'll move on to the last part of kinematics, which is relative motion. So if any of you have doubts from the first worksheet of kinematics or from HC Verma, please drop me a message with the question number on the text message and we'll discuss those. So Adinath, I've received some doubts from you earlier. So the questions you sent from HC Verma are from the kinematics chapter, I'm thinking. So should we discuss those first? So let's start with these questions. Right, Adina, these are the questions you had sent me earlier for. Okay, so we will start with these. In the meantime, if anybody else has doubts in HC Verma or in the 1D motion worksheet, the first worksheet of kinematics that I had sent, please send me a text message with the question numbers. That will be enough. I'll discuss those. Okay. Right. So just going through question number 12. Okay. If you have HC Verma, please refer to the book. I'll explain the question in a moment. Okay, 11th also. Fine. So let's start with 11th. So these are both graph-based problems. So question 11 has a graph of x versus t for a one-dimensional motion. And it says that we have to find a time t such that the average velocity of the particle during this period from 0 to t is 0. Okay. So I'll just tell you the general idea how to deal with a question like this. Of course, in this, the graph is not made with graph paper. So you have to do some estimated calculation. Okay, Priyam will pick up those questions immediately after finishing the 1D questions. Okay. So I'm starting with question 11 actually of HCB. So in 11, we are just given a graph of a position versus time graph for 1D motion. And that graph has a general shape which is something like this. Starts from 20, x equal to 20, dropping down to some value like this. Then eventually going back to some value like this. Okay. So this is where we'll have to actually estimate because exact values of are hard to. So we have to find the time at which our average velocity should be 0. So average velocity is basically what in 1D motion it is displacement upon time. Okay. So at t equal to 0, you can see the x coordinate is 20. So at some time t, if the x coordinate again becomes 20, then you can see that the displacement will be 0. So average velocity will be 0. So what we have to do is we have to draw a horizontal line from here and see that the x coordinate is again becoming 20 at some particular time. Let's say this time is t1. So the answer to this will become that t1. Okay. So you can, try to do a sort of exact kind of calculation here by just using a scale and a pencil on the graph and try to divide the time intervals that are shown into equal halves or equal divisions and estimate this and all that. But generally speaking, this is the method. So you will not get a question in JEE like this where you have to do so much guesswork. Okay, if there's a graph based questions from which you have to do calculation, the graph will actually have more number of divisions from which you can actually calculate. But this is the concept. So Adinath, hope this question is clear.
Yes, sir. Sir, so we can say that the time lies between 10 and 20. We can be sure about that, but not the exact value.
Yeah, it's somewhere between 10 and 20. And I think if you just do a rough diagram with this using a pencil and a scale, you will see that you'll get the time probably somewhere around 12 or 11 point something seconds like that in this particular graph. Okay. Okay, now the 12th one is similar question, but a little bit more tricky. So in 12th question, actually what's happening, it's a two-dimensional motion. So the graph is the XY plane. So it's not a time-based graph, it's a position graph. And we have to find the position B at which such that the average velocity between A and B has the same direction as the instantaneous velocity at B. So this is, it looks like a similar question because it's a graph, but it's a much more tricky question because first of all, it is not a 1D motion. It's a 2D motion because it's the XY plane that they're plotting. So in the XY plane, there is some kind of a graph drawn, which is actually the actual path along which the particle is moving. Okay. So that path is shown again something like this. And this point is A. Okay. So it is given that a particle starts from the point A. So let's say at t equal to 0, the particle is at the point A and travels like this along this path. Now at some point of time, at some time t, let's say, it is at some position B, okay, such that okay, the average velocity is it or the displacement such that the average velocity between A and B, so V average between A and B should be in the same direction. It should not have the same value, but it should just be same direction as instantaneous velocity at B. Okay, so first of all, let's understand that given a trajectory like this, how do we find the direction of average velocity? So if we have any xy plane motion like this, suppose some motion is taking place like this. Now if I ask you that at some time t1, the particle is at A, and at another time t2, the particle is at B. So what is the average velocity from t1 to t2 time, or that is A to B? So that average velocity as a vector is the displacement from t1 to t2 divided by t2 minus t1. So in the graph, that displacement you realize is basically this vector. It's the vector joining AB. This exact vector, this is the displacement from A to B. So that is this displacement from A to B divided by the time interval. So you can see that the direction of this velocity vector, this average velocity vector, will be the same as the direction of the average as the displacement. So is this point clear, Adinath?
Yes.
Okay, that's it. Okay. Now, similarly, if I ask you that what is the direction of instantaneous velocity at some point, some random point in the graph, let's say P. So I've selected this point as the random point, suppose this point P. So at this point, what is the direction of instantaneous velocity? So instantaneous velocity kya hota hai? It is instantaneous rate of displacement with respect to time. So that means in this graph, what I have to do is I have to magnify it as much as possible. And then in that magnified version, I have to draw a very small displacement. Na? So that small displacement will look like this. So this will be ds. Okay. So ds by dt will be along this direction only. So the instantaneous velocity at that point of time will be along this direction only, because that v is ds by dt. So what this tells us about instantaneous velocity, it is along the tangent at that point. Instantaneous velocity is along the tangent at a given point. Okay, this is clear, Adina?
Yes, sir.
Whereas average velocity is along the line AB, okay, or the displacement vector from A to B. Okay. So now if you correlate that to this question, you will come to realize what they are saying. I have to find some point B where the instantaneous velocity has the same direction as the average velocity. So instantaneous velocity का direction क्या होता है? Tangent होता है. So for example, if I take some point over here, okay, if I took some point P over here, the tangent you can see is like this. Okay. So the instantaneous velocity's point direction at this point of time would be something like this. Okay. But what about the average velocity from A to B? That would be along this line. It would be along the line that is joining A with that point B, na? Because this would be the displacement. So the average velocity would be in this sort of direction from A to B. So they're not matching the directions. Okay. So this is not that sort of point. So where would B be? Most likely it would be somewhere over here. That when you draw this tangent from here, it should coincide with that point. So if B is over here, then you can see that the instantaneous velocity at B is along this line. Okay. And the displacement from A to B is also along the same direction. So that means the direction of average velocity is the same as the direction of instantaneous velocity. This would be the displacement from A to B. So this is in the same direction as this. So this is satisfying this condition. So quite an interesting and technical type of question to do with graph concept. Okay. Slope of tangent, instantaneous rate of change, all these things become important to me. Basically things we've learned in calculus. Hope this is clear, Adina.
Yes, sir.
Okay. So again, it is a little difficult to give the exact answer, but from the way the graph is drawn, you will see it is somewhere between 5 and 6, probably exactly at the point 5, maybe 5 seconds or little bit after 5 seconds, 5 meters on the x-axis, that is. So position of that point B would have x equal to 5 and also probably y equal to 5 or something pretty close to that point, which is like the local maxima or a point of that point of that curve, right?
Yes, sir.
Okay. All right, moving on. Now next, I'll go to question 21 unless somebody else has anything else. No. Okay, so we'll complete question 21 next of the same exercise from HC Verma. So go through 21. I will explain the question to you. Okay, so it's the case of a jeep chasing a motorbike. Now the bike crosses a certain turning point at a speed of 72 kmph and jeep is following at 90 kilometers per hour. Okay, and it crosses the same turning point 2 seconds later, sorry, 10 seconds later. Now assuming that they move at the constant speed, how far from the turning point will the jeep catch up with the bike? Okay. So basically here what's happening is that speed is constant. So kinematics wise, the concept you'll be using is that when speed is constant, then distance traveled is speed into time. Right? You're following, Adina?
Yes, sir.
Okay, so let's say this is the kind of road. Okay. And somewhere here we have that turning. So let's say we first observe the situation where the motorbike is just reaching the turning. You're taking this as t equal to 0 and it's going to turn and go like this, but at a constant speed of 72 kilometers per hour, which will be 20 meters per second, right? To 5 by 18. Okay. And at that point of time, the police jeep is somewhere behind, moving at a constant speed of 90. So that is 19 to 5 by 18. So that is 25 meters per second. Okay. Now, these are going at constant speed. Okay, so it's also shown that the jeep reaches here at t equal to 10 seconds. Okay. And by then, let's say the motorbike is here. And then eventually after this frame, because they're moving at constant speed, so eventually the jeep will catch up with the motorbike. So the motorbike and the jeep are both at the same position at some time t, which we have to calculate. So the jeep reaches here in this much time. That means this initial distance between them is equal to how much? It is 25 meters per second into 10 seconds. So it is 250 meters. So at t equal to 0, the jeep is 250 meters behind the bike. Okay. So at some general time t, the distance traveled by the bike is 20t, and the distance traveled by the jeep is 25t. So if at this time the jeep catches up with the bike, then the jeep should have traveled an extra distance compared to the bike of this. So 25t, that is a distance from here to here, where they have caught up. Okay. That should be equal to the distance from here to here, which is 20t, which the bike has traveled, plus an additional d, which we saw is 250 meters. So from here, you see that the time is 250 by 5 or 50 seconds. So they would catch up after 50 seconds. Priyam, these questions you're asking are from HCB only, right?
No, sir.
Then from
So from the worksheet which you can projectile motion.
projectile. Okay, I'll come to those.
Could you please
So,
T equal to T?
sorry.
Could you please re-explain from T equal to T?
So at this time, basically what's happening, at this time, what is the total distance the bike has traveled, speed into time, and what is the total distance the jeep has traveled, 25 into t. But in the diagram, you can clearly see that from t equal to 0, that is when they were both at the red positions, till time t, where they are both at the violet colored position, what are the distances traveled? The distances are traveled such that the jeep has traveled an extra distance of d. No? So the jeep should have traveled the total distance traveled by the bike plus covered up the initial distance of 250 meters. So this is the relation.
Okay, sir.
Is it clear now? Okay. So basically the only formula you're using is that when speed is constant, then distance is speed into time. The rest you're just using the geometry of the question the way they've given. So they've given some information from which you can see that initially the distance between them is 250 meters. So by the time they catch up, the jeep should have covered up that 250 meters. No? So it has traveled an extra distance of 250 meters. So that's basically the idea that we're using. Okay, so hope this one is clear. Now moving on, question 22. let's take a look at that question. Yeah, so just try and make a diagram for this question. Okay, I'll explain it to you. Once you make the diagram, it will be very easy to understand how the question is happening. But in the diagram, clearly show that each of the cars is 5 meters long. Okay, and initially at t equal to 0, okay, the car which is moving at 60 kmph, assume that it's just about starts to overtake. Okay, that means the front end of that car which is moving faster is just come alongside the rear end of the other car which is moving slower. So that's when the overtaking maneuver just starts. Okay, and eventually when it completes the overtake, then it's the other way around. The faster car's rear end is just alongside with the slower car's front end. So if we just show this in a diagram, it will become clear exactly how we're solving this question. So they're traveling at 60 and 42 kilometers per hour respectively, and they are both 5 meters long. So making use of that information, you will see that can represent the situation something like this. Okay. So let's say this is car A. This is the one that is moving faster. This car B. So this I'll take as my t equal to 0. This is when the overtaking is just starting to happen, because A is just about going to come alongside to B and start overtaking it. So this is when the overtaking starts. And eventually at some time t, when A has completed the overtaking, this is what happens. A is here and B is behind it. So when the front end, rather the rear end of A has just gone past the front end of B, so just about it's alongside, that is when the overtake maneuver is completed. So this time we want to calculate, and what is given to us is that the length of this car is equal to the length of this car, which is equal to 5 meters. So to find t, I'll just give you a hint. Here you can see that in this diagram, if you look at this, this is B's displacement during that time. So it is VB into T. And similarly, if you look at this, this is A's displacement. That is VA into T. Now use this relation over here to find out how much that time is. And then we'll talk about the road length also. Okay. Both are moving with zero acceleration. They're moving with uniform speed. Okay. So calculate the value of time and just send it to me in text message. It's quite easy. Yes, very good. So basically what you can see here is that this is the length of car here, which is 5 meters. And this is also 5 meters because they are both 5 meters, the lengths. Okay. So displacement of A should be displacement of B plus the sum of their lengths. So this is 500 by 3, right?
So 50 by
Yes, sir. 50 by 3.
Oh, sorry. 50 by 3. So 16 point. Just per second. And this one is
11.6.
so 50 by 3 into T should be equal to T equal to 2 seconds you'll get. Okay, so that's simple. Now, what about the road length? We can do by relative velocity also, but I'm avoiding relative velocity concept because I haven't taught that yet. But the time will still be 2 second stages because in the relative motion also you'll see that the displacement will have to be 10 meters, not 5 meters, because it's crossing it completely. Okay, now the road length is this section of the road. From here to here, this entire section has been utilized to complete the overtake. So this is the road length. And that road length you can see is the displacement of A plus its own length. Okay, so 100 by 3 plus 5, so that will become 38.33 meters approximately. This is the road length that is utilized for completing the overtake. Okay, so hope this question is also clear. So just make a note of this if required, and next we are doing 24th question. So go through it.
Sir,
Yes.
sir, if in the question it was given to find calculate road width, then how should we proceed?
Road width की तो जरूरत नहीं है ना बेटा. We are assuming the road is wide enough to accommodate both the cars. Like if it was saying that it's just about accommodating both the cars and the individual width of the road is given, that's a different matter. You'd add the two widths of the cars. You understanding?
Sir, could you please explain one more time?
बेटा width of the road तो आपको ये दिख रहा है ना. This width has to be greater than the sum of their widths. Otherwise the two cars cannot be alongside. That's the only condition. It's not something which is based on time and speed and all that. No?
Yes, sir.
Okay, let's come to question 24 next. So it's saying that a ball is being dropped from a balloon which is going up at a speed of 7 meters per second. If the balloon was at a height of 60 meters at the instant when the ball was dropped, how long will the ball take to hit the ground below? So the main thing you have to understand in this question is that you're dropping the balloon, rather the ball from the hot air balloon. Okay. So with respect to the balloon, it's starting from rest because you're dropping it from that object. Okay. But the balloon itself in the ground frame is moving. No? So with respect to the ground, when you drop this object from a certain height above, what is the initial velocity of that object? It will be the velocity of the balloon only. So when you drop this object, it has an initial velocity upwards equal to 7 meters per second as far as a person on the ground is concerned. As far as the person on the balloon is concerned, it's starting from rest. But in the ground frame, it's having an upward velocity. So at t equal to 0, if you dropped it from the balloon, it's actually first going to go up and come down. Okay. So taking our y-axis as upwards, we can take u as plus 7 meters per second. We can take acceleration as minus g or minus 9.8 meters per second square. And whenever it hits the ground at some time t, the displacement should become minus h. Okay. So that is minus of, how much was the height given? 60. So from this you can see that y is equal to 70 minus 4.9 t square. So minus 60 should be equal to 70 minus 4.9 t square. So from this we can calculate the value of time. Approximated up to first place of decimal, it will be like this. Okay, so Adinath, hope this question is also clear.
Yes, sir.
Okay, good. So now we are moving on to some questions from the projectile motion worksheet. So we will start with question number 9, 13 and 15. So next thing we'll look at is these questions. So please refer to the projectile motion worksheet we'll discuss. Let's start with the 9th question. Okay, so in fact, we'll start a little before that. We'll start with question number 2 and 3. Okay, so just go through question number 2 and 3 and discuss and explain. Okay, so in question 2, what you should do is just develop the equations of motion. Okay. The motion is happening in a two-dimensional plane. So actually, this is not just projectile motion, but it's also general 2D motion. So question number 2 is actually not a projectile motion question. It's a general 2D motion question. Sorry, I couldn't hear you, but
तीन तरीके से फास्टिंग होता है ऐसा करते हैं ऐसा नॉर्मल एक एकदम बैक साइड वा आणि एक असं दोन्ही हाताचं करून
Anshul, are you asking some question? I'm not able to hear you. Okay. So imagine you have like a smooth surface like this. Okay. And on this, an object is given some initial velocity u, and also as it is moving, it has some different acceleration e. So it'll have a path which goes like this. So that is what we have to solve over here. So that's what's given. So an ice boat sails across a frozen lake with a constant acceleration produced by the wind. Okay. So at a certain instant, the boat's velocity is given to us. So we'll take that instant as t equal to 0. So that is the initial velocity. It's given as 6.3 I cap plus 8.42 J cap meters per second. Let's take that time as our reference time, t equal to 0. And its acceleration is given to us as constant. So we don't know how much that is. So it's got some x component, some y component, where these are known quantities. Okay. Now it's given that 3 seconds later, the boat is at rest. So at t equal to 3 seconds, the boat's instantaneous velocity becomes 0. So we have to find the acceleration. It's asking for average acceleration, but basically because the acceleration is constant, so average acceleration is the same thing as instantaneous acceleration. So we'll discuss. So we have to find the value of A. So again, what you can do is divide the motion into components: X component, Y component. So you can see Ux is equal to 6.3 meters per second. Ax is an unknown quantity. Uy is 8.42 meters per second, and Ay is an unknown quantity. So from this information, we can see that at some time t, your x component of velocity will become 6.3 minus ax into t, and your y component of velocity will become 8.42 minus ay into t. So velocity in general, sorry, plus, those values will be negative. So velocity in general at time t will become 6.3 plus axt I cap plus this much j cap. Now this velocity is 0 at t equal to 3 seconds. So just substitute that. So that means that so the x component of acceleration is minus 2.1 meters per second square. But along with this, our y component of velocity should also become 0. So that means 8.42 plus ay into 3. This term should also be 0. So from this we are getting that ay is minus of 8.42 divided by 3. So that is minus of like this. So the acceleration vector is okay. One shall come to your question also. Now next we look at question 3. So finish writing this down if required and move on to question 3. Same type of method in question 3. Okay. Only now you have to find the displacement as a function of time so that you can find the x and y coordinate of the particle as a function of time. And then you have to find the time at which the x coordinate reaches its maximum. So take the same approach with your velocity and acceleration given in component form. You divide the motion into x and y components and find their displacements along the x-axis and displacement along the y-axis, that is x and y coordinates as functions of time, and proceed from there.
Sir, is there a misprint in the question? Both are given in JCAP.
Okay, so let's figure this question out. So it's the same type of question, but what has been asked is a little bit more, like you have to calculate a little more over here. So the initial velocity in this case is 3 I cap in meters per second. The uniform acceleration, so this is at t equal to 0. And the uniform acceleration, just make a correction. Both the components are given as j cap, but one of them should be I cap. So this is I cap, and the second term is the j cap one. So it is minus 0.5. So this is the uniform acceleration. Okay. Now from this data, what we have to calculate is we have to calculate the velocity when it reaches the maximum x coordinate and the position. So we have to find the velocity and position at the instant when the x coordinate is maximum, is what we have to calculate. Okay. T equal to 0 is starting from origin. Starting from the origin. Okay. So divide the motion into individual components, okay, and y. So you will see ux is 3 and ax is minus 1. So at some time t, your x coordinate will be 3t minus 0.5 t square, and your x component of velocity will be 3 minus t. So this is the more important equation for us. And your uy is 0, and your y component of acceleration is minus 0.5. So at some time t, your y coordinate will be minus 0.25 t square, and your y component of velocity will be minus 0.5 t. So now we have to do this. So we can see that x as a function of time is like this. This is your x coordinate as a function of time. So it has that quadratic parabolic kind of situation. So x coordinate becomes 0 again at 6 seconds. Okay. So in between you can see at 3 seconds, the x coordinate reaches its maximum value. So from this we can understand that x is equal to 0 at t equal to 0 and t equal to 6 seconds, and x is equal to its maximum at t equal to 3 seconds. So you can even find the x's maximum value as so the maximum x coordinate that it reaches is 4.5 meters. But more importantly, so at t equal to 3 seconds, when x is equal to its maximum value, Vx is equal to 0, okay, and Vy is equal to, so the velocity at that instant is minus 4.5 j cap in meters per second square. And the y coordinate is minus 0.25 into t square. So that is so the position is, so this is the complete solution to this. So it is somewhat similar to the type of derivations we had done in projectile motion, but the difference is here the acceleration has both components and the initial velocity has only x component. Whereas in projectile motion is like the opposite. The initial velocity has both x and y components, whereas acceleration is only having one of the components, that is the negative y component. But rest the method of solving is the same. Okay, so that's the third question. Please go through this carefully. Let me know if there's any doubt.
Sir, can you scroll up a little bit?
Before third question, you mean? Second question.
Yes, sir, just the down
Okay.
part, that acceleration part.
Okay. So that's the third question. Next, we'll be looking at 9th and 13th.
How did you get Vy as minus 0.5 t? Shouldn't
How
it
we
just
got V by nas? So, okay, see, this information is given. So from this, as a formula, Vy is equal to Uy plus Ay into T. Okay. And Y component of displacement. So we're just using the 1D equations, but along the y-axis. Got it now?
okay? Okay.
So can you show the last part of this question?
Yeah. I'm sure. So finish this up and then we'll discuss 9th question. Okay, now 9th question is a projectile motion question, which is a bit calculation heavy in the sense that there is that angle of 26 degrees and also we'll have to make use of trigonometric tables or a calculator or whatever. But first, let's understand the question. So on a baseball field, from somewhere where the batter is present, okay, when you hits the ball, it's projected at a velocity u at an angle theta. So this position from which it is projected, that is 3 feet above the ground. Okay. And then at a certain distance, there is the wall. So if you've seen baseball, you will see that the wall is pretty tall usually at the boundary, and the fielder is supposed to jump against the wall. Okay. So this distance of the projection point to the wall, this is given to us as, I think that's 138 feet, right? Sorry, 386 feet. Also, we have to do the calculation in the FPS system, feet pound second. So in this case, feet. Okay. So this is projected at a speed of 132 feet per second at an angle theta is equal to 26 degrees. And we'll take the value of G as 32 feet per second square, using the conversion that 1 meter is approximately 3.05 feet. So what happens is that this ball, like let's say somewhere over here, and the fielder at the boundary jumps such that when he's jumping, his hand is at a height of 7 feet above the ground. So he still misses the ball by a certain distance. So he misses the ball by this distance, let's say h. So we want to calculate how much this h is. So what we'll do is the standard thing. We'll take the point of projection as our origin, horizontal as our x-axis, vertical as our y-axis. So we'll write out the equation of trajectory. Okay. So this point where the ball goes and hits the wall, this point will take its coordinates as x1, y1. Okay. And from that we'll calculate everything. Okay. So first of all, the trajectory, the equation of trajectory is x tan theta into 1 minus x by r, where r is u square sine 2 theta divided by g. So in this equation, the point P, its x coordinate is actually d, 386 feet. The y coordinate we have to find out, and then our height h will actually become 7 minus 3 subtracted from that y coordinate. The distance by which he misses it will be y1 minus 4. So this is what we need to calculate. Okay, so let's start with the equation of trajectory. So tan 26 degrees, when you look it up on a table or on a calculator, you will see it's quite close to tan 30, but we'll take a more accurate value of it. So 26 degrees tan is about 0.49. Which we will approximate here for our purpose as 0.5. Then this R, which is so sine 52 will again be very close to sine 53. So nearly 0.8. Okay. So it's 0.79. So this R will come out to be, when we calculate it, So my equation
Sir,
of
it will be in
trajectory,
feet.
sorry, come again.
Sir, it will be in feet now, 435.6 feet.
Not able to hear you clearly, beta. Speak a little louder.
Sir, the range will be in feet now.
Sorry. Yes, yes, it will be in feet. Correct. The unit of it correctly pointed out is in feet. Okay. So my equation of trajectory, this one, is with the numerical values, is becoming 0.5x into 1 minus x upon. So now substitute the coordinates of the point P. So x1 is 386 feet. Y1 we want to calculate. So y1 should be equal to 0.5 into x1 into 1 minus x1 divided by the range. So from this we'll get y1, just directly doing the calculation. So 386 divided by 435.6. So that's about 0.89. So 1 minus 0.89 will give us nearly 0.11. So that into 386 into 0.5. Just check this value once more. Just give me a moment. So just complete the calculation from this. I'm just checking the values once more. Okay, so actually, if we take this value instead of the approximate value, we get a slightly different value here. It is closer to about 430. We take a different value. Significant difference to the value of y you will see. Yeah, so we'll get y1 as about 19.75 feet. So now you can see that the distance by which he misses is actually that y coordinate minus 4 feet. So it is about so the question is calculation heavy, but the concept is quite simple otherwise. Okay, you just have to use equation of trajectory is the clever method to use. Avoid the time-based equations because then you'll have to find the time and then eliminate the time in the equation to find the distance by which he misses and all that.
Sir, how
Yes.
to find this tan 26, this values in exam?
So in exam it will be given values, beta. Okay, either that or the table will be given to you in the paper. So you will have to look up the table. Okay, so this was the 9th question. So next we are doing 11th and 13th. So after completing going through this, go through question 11 and 13. Discuss those two. So 11th question also you can use equation of trajectory, and it's a question with the regular units in SI system and angle 37 and all. It's going to be quite easy to solve it. Just try and Okay, so let's pick up the 11th question. Yeah, once I will pick up your question also after I complete the worksheet doubts. Okay, just give me a little bit of time. So ball is thrown with a speed of 20 at an angle of 37 from the horizontal. It lands on the roof of a building at a point which is 24 meters horizontally from the throwing point. So to find the height of the roof. So this is a question that you can do directly using equation of trajectory quite easily. Let's say the height of this building is unknown, but we are projecting an object at a speed of 20 meters per second at an angle of 37 degrees at a distance of 24 meters. Lands on top over here. So we have to find the height. So you use your standard equation of trajectory. So first find the equation of trajectory, and in that put the x coordinate as 24 meters. The y coordinate would be the height. So you can see this becomes 2 and 2. 16 into 12. So y is 3 by 4x into 1 minus x divided by 38.4. So now you put the coordinates of that point where it's hitting the rooftop. So this point has an x coordinate equal to 24 meters, a y coordinate equal to h. So h is equal to 3 by 4 into 24 divided into 1 minus 24 by 8. So from this you get the height. Okay, so straightforward enough. This question, I think it should be easy. Moving on to question 13 next. Was it 15? Okay, 13, 15 and 18. Okay. Okay, in the meantime, Vansh, I will answer the question that you have asked. This question. Let's see. Question. So a truck is traveling due north at 20 meters per second, and then it makes a turn towards the east and traveling at the same speed. So what is the change in velocity? Okay. So the change in velocity delta v is the final velocity minus the initial velocity. Now final velocity is basically what it is, 20 meters per second towards east, and the initial velocity was 20 meters per second towards north. So we take this as a north, south, east, west direction. We can see as vectors. Our initial velocity was this one. And after making the turn, the final velocity is this. So the change in velocity, final minus initial, is this. So this is our delta V. Okay. So you see that this has a magnitude of 20 root 2 meters per second, or approximately 28.3 meters per second. Okay. And the direction is like this. So it is in the
Southeast.
southeast.
Okay. I had a thought कि like resultant निकालना था और ऐसा.
So you understood now, here it's,
Yeah.
instead of resultant is the difference. It's final minus initial.
Yes, sir.
Okay. Okay, let's come to that question number 13 from the worksheet. So that's actually pretty simple question. So what's happening is that you're throwing a baseball, let's say at a certain height from above the ground, at a given speed at a given angle. Okay. And at the instant when you're throwing the baseball, there is another player who's present somewhere here. His hand is at the same level as the ball where it is thrown. Okay. But he's at a distance of 50 meters. So to figure out where he should run so that he's able to catch the ball at the same level. So first of all, you have to find the range. Okay, so u is given to you, theta is given to you. So the range from that will come out to be u is 20 and angle is 45. It's pretty simple. So the range will come out to be 20 square into 1 divided by 10. So it is 40 meters, right? So that means the ball will land somewhere here at t equal to capital T. So that will be 2 seconds. So the person will have to run this much. So you'll have to run a distance of 10 meters towards the throw in capital T equal to 2 seconds. Okay, so hope this question is also clear. Moving on to 15th after this. So in 15, let's say you're firing with a gun on a target which is over here. Okay. But you'll have to aim the gun, the nozzle of the gun at slight angle so that this happens. So when you aim the gun, it'll have to be aimed at an angle such that to draw the straight line, you're actually aiming at this point. So you have to aim at the point P higher up to hit the target. So if the angle of projection is theta, okay, and this distance from here to here is d, so you'll see that h by d is equal to tan theta. So the height above at which you'll have to aim is d tan theta. So this we have to calculate. Okay. Now actually what is happening? The range of the projectile should be equal to d. So u square sine 2 theta divided by g should be equal to d. Now we'll see the values are such that here we'll be using small angle approximations. Okay. U is a huge amount. It is 1500, I think, right? Yeah, 1500 feet per second. And the distance d is only 150 feet. So take g as 32 feet per second square. So this equation becomes 1500 square into sine 2 theta divided by 32 is 150. So getting sine 2 theta (1500 into 10), right? So 15,000. So getting sine 2 theta nearly as, so 1 by 500. So nearly as 0.002. So now see, you can see sine 2 theta is very small. It's a very small value. So you can use the small angle approximations for theta being a very small angle. Sine theta is approximately equal to theta, which is approximately equal to tan theta. So here 2 theta is approximately 0.002. So that means theta is approximately 0.001 radians. So now to calculate this height at which you are aiming above, calculate this height. Now tan theta will approximately take as theta. So if you convert that to inches, it is about about 1.8 inches. So because the bullet is fired at such a high speed of 1500 feet per second, so even though you're firing from very far away, 150 feet, the effect of gravity is very less. Why the effect of gravity is very less? Because the time of flight is very less. Because your velocity of projection is very high, so it crosses that 150 feet in a very small amount of time. So the effect of gravity is extremely small. You have to only aim 1.8 inches above. But of course, if you aim directly at the target, you will not be able to hit the target. You will actually miss the target below. The bullet will fall below the target by 1.8 inches. So this is to show you the typical type of calculations that snipers do when they are, making sort of physics type of estimates to how to adjust the position of the aiming to account for things like gravity. Of course, in real life, snipers also have to account for wind resistance because there will typically be some significant amount of air which is, or wind which is present, wind velocity. And the typical shape of the bullet is such that, even though it cuts through air, it is affected by wind. But here we are assuming it's still air, there's no wind. So in that case, the bullet will only fall through a distance of 1.8 inches vertically. No other deviation will happen from the path. So we'll have to aim the gun at the point P. Okay, train its nozzle or the muzzle of the gun above the horizontal at an angle theta, aiming at the point P, which is 1.8 inches above the actual target, so that the bullet, when it goes in the actual projectile path, it will hit the target exactly. Okay, so hope this question is also clear.
So we have to assume now that the target and the rifle they are along the same X line.
The target is directly in front of where the gun is. You have to make that assumption here. Okay, the target is not at the top of a building, or we are not firing from a building to a lower point or anything like that. That is the assumption we are making because nothing else is given to us in the question, right?
Yes.
Okay.
So also, sir, don't we have to fire at the height of the projection to hit the target?
Sorry, come again. We have to
Aim at the height of the projection at the highest point.
no. We are aiming at the point P, like I'm showing in the diagram, because your gun has to be aimed in such a way that the nozzle of the gun is at the same angle theta as the projection angle. No? You understanding?
Yes, sir.
So in the diagram, the actual path of the bullet is the red dotted curve. That is the projectile path. Okay, but the nozzle of the gun, how it is aimed? It's aimed along the hypotenuse of this triangle, to the point P. So that's how we are, so we are calculating theta using the range formula and all that. But then we are also solving the trigonometry of this triangle. Okay, that in this triangle, this angle is theta and the base is d, which is 150 meters. So how much is the height h? So that tells us that how much above the target we have to aim the gun, so that the gun is at the proper angle with the horizontal. You understood the concept now? Okay, next we are moving on to question number 18. Just go through it, we'll discuss.